So in science, we've been talking about gold and the history of the discovery of gold in California. Well, today we are actually going to be learning a little bit more about gold and then working on math using combinations of gold as well. So I'm going to go ahead and read to you this article by Carl Gelb, and it is about gold. People have valued gold for thousands of years. Because of the metal's durability, gold ornaments, statues, and jewelry look as brilliant today as when the artists of Egypt and other cultures crafted them thousands of years ago. Gold is one of nature's true wonders. So I'm going to just put a box around this word durability, and we have some context clues as to what this word might mean. And it tells us that gold today looks just as good as it did thousands of years ago. So that would mean that durability is basically something that can last for a very long time. It is durable. And I'm going to write that on the side. It's durable. Okay, the next section we're going to be reading about is properties. Gold is an element. It cannot be broken down into simpler substances. Gold is also very malleable, which means it is easily flattened into thin sheet. Malleable means that you can work with it easy and kind of manipulate it into other forms. Gold is also ductile, which means it can be pulled into a wire. For these reasons, gold is useful in making jewelry. 1 ounce of gold can become 187 square feet of gold leaf or 1 mile of gold wire. Gold also conducts heat and electricity very well. Alloys. Pure gold is very soft. Because it's so soft, gold is often mixed with other metals to make a mixture or alloy. So an alloy is a mixture that is stronger than gold alone. Adding silver, copper, and zinc to gold produces the color we associate with jewelry. Today's uses. In the past, gold was mainly used for jewelry, statues, and other decorations. But today we use gold for more than just its beauty. It is an excellent conductor of electricity. This means that electricity flows through it easily. As a conductor, gold coats electrical parts inside our cell phones and computers. It helps speed the flow of electricity. Thin films of gold also reflect radiation on satellites, the sun visors of spacesuits, and the windows of skyscrapers. Gold's uses are many and important. So now we're going to move on into our actual math problems today, and I'm going to go ahead and try and show you how I would set up these problems so that it might make it a little bit easier for you to work through them. So number 1 says, a jewelry maker buys a bar of pure gold. She needs 6/8 of an ounce of pure gold to make a piece of jewelry. Unfortunately, she does not have any measuring tools that measure in eighths. What fraction is equivalent to 6/8? Use a model to show a fraction that is equivalent to 6/8 and label the model. So we can use a couple different fractions, 6/8. So what I'm going to go ahead and do is I created a bar model here, and eighths are one of the easiest of all the fractions to mark because you simply keep subtracting your space by halves. And although there are dots on here, that's just because my pen bled, but I'm going to just kind of visualize what half might look like between of this object. So that represents 1/2 right there. And I'm going to go ahead and do a half here as well. And then I'm going to half this space again. And you see that by going in half the first time, I get 1/2 and 1/2. When I half the halves, I get 1/4, 2/4, 3/4, 4/4. Well, now I have to halve these spaces, and I actually get eighths. I have 1/8, 2/8, 3, 4, 5, 6, 7, and 8. And she needs 6/8 of an ounce. So I'm going to go ahead and highlight that. That'll be 1, 2, 3, 4, 5, and 6. This is 6/8 of an ounce. And the question asks us to make an equivalent fraction of some way that she might be able to measure, or this jewelry maker might be able to measure. So I have already halved the one below, and unfortunately, just simply making it into a half doesn't get me that 6/8. So I'm gonna go ahead and half them again. And remember, these are gonna be kind of equal parts. So we're gonna wanna make sure that they measure up. And you can see here that now the distance of the second bar is the same as the first bar because I've made them both into equal parts. So your job is to figure out, what does this right here represent? This 1, 2, 3 out of 4 represent, and is that an equivalent fraction to the 6/8? So now moving on to our next one, number 2. A jewelry company makes equal-sized alloy bars to sell to local jewelry makers. Each bar contains 4/10 of an ounce of pure gold, 3/5 of an ounce of silver, and 2/3 of an ounce of zinc. Which metal is used the most in the alloy? So it basically wants us to compare 4/10, 3/5, and 2/3. Now you can do that by actually drawing them out, which I'll do here in a minute, or you can actually try to make equivalent fractions. So I have 4/10 and 3/5. Now remember, because 5 is a factor of 10, I can go ahead and try to make this denominator 10, and I know I can do that by multiplying it by 2. So then I would multiply this top one by 2, and I would get the equivalent fraction of 3/5 with a denominator of tenths, and then I can compare that with 4/10 to see which one is more or less. And then I can also do that with the 3 down here below, but unfortunately I'd have to convert all of these to the same, and the common The common denominator for each of those would be the multiple that they all share in common. Why do I keep writing 40? Which is going to be 30. It's going to be that common multiple. I'm sorry. So it'd be 4/10, and then how do I get to that denominator of 30? Well, I'd multiply by 3, and then I'd multiply the 4 by 3, and I'd get 12/30ths. And then you do it to the 3/5. 3/5 has to become, the denominator has to then become the 30. Another thing you can do is you can try to write these out. So the 3, I'm gonna go ahead and start with my 4/10. I'm gonna try to break up this top line into tenths pretty equally. And I went a little further, so I'm over here on this line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. So I go from 0 to 1. And my 4/10 would be 1, 2, 3, and 4 on my tenths line. And then I could do the same. I could break up this one below by fifths as well. But because I've already converted the 3/5 and given it the denominator of 10, I'll know where this one falls on this line as well. But we could go ahead and attempt to make those into 5. And that would be... Okay, and then the 2/3, I'll just visualize maybe how this might be broken up as a 1/3 and then a 2/3 right there. And then using these lines, so again, this one represents the thirds, this is broken up into fifths, and this one into fourths. And then you can make a comparison either mathematically or how it looks on a number line like that. Okay, so number 3. Quinn is making an alloy of gold and silver, so a mixture combination. She mixes 6/10 of an ounce of gold and 4/10 of an ounce of silver to make the alloy. She then uses 3/10 of an ounce of the alloy to make a necklace. How many ounces of the alloy does Quinn have left after making the necklace? So we know that the necklace is the 6/10 plus the 4/10, and this will get me some answer. And then she's gonna end up using 3/10, which is gonna be the answer minus the 3/10, and that will get you your final answer here at the bottom. Okay, second to last problem, number 4. In one day, a cell phone maker uses 2/8 of an ounce of gold for all the conductors in the phones it makes. It also uses 1/8 of an ounce of gold for all the electrical coils in the phone. How much gold does the factory use each day to make cell phones? This is simply an addition problem. You're going to add up the two amounts and write your answer down. And then number 5, a jewelry store has 12 golden nuggets to use to make jewelry. They use 3 nuggets to make earrings, 4 golden nuggets to make rings, and the rest of the golden nuggets to make bracelets. What fraction of the golden nuggets does the jewelry store use to make the bracelets? So we have earrings and rings. So we know that we're going to take away 12 minus the 3, and we're going to get our answer is 9. And then we're going to take away the 4, and that is going to leave us with 5. Now what you're going to do here is you're going to figure out what fraction the 5 left over would be out of 12. And one thing you can do is you can draw it out and break this up into 12 equal pieces and mark in the 5. But essentially it is what fraction is left to make. So, and one way you can think about it is you can go ahead and say, well, 3/12 of the golden nuggets is used to make earrings, and 4/12 is used to make rings. So the rest over 12 percentage, the fraction, is used to make the bracelets.